Hello everyone, we are presenting our BTech project Drishti Vision for Blind developed by Group G06 from the Department of Computer Science and Engineering at DY Patel College of Engineering and Technology. Our team consists of 5 dedicated students Rohit, Vaibhav Patil, Ram Gavade, Wasif Patel, Prasad Magdum, and we are guided by Mr. V.V. Mangave. Today we will walk you through our innovative solution designed to assist visually impaired individuals in navigating the world independently. Our project is structured in 12 key sections. Let's begin with introduction. Blind people they face difficulty in moving independently in daily life. Lack of vision make navigation unsafe and challenging. Detecting obstacles and finding safe path is a constant struggle. This often leads to accident or dependency on others. So a mobile-based application can assist in safe movement. It uses camera detection and voice alerts to guide blind people. Now let's see literature survey. Our project is built on solid research foundation. We have reviewed 3 key research papers. The first one is You Only Look Once research paper by Joseph Redman, which introduced us to YOLO model, an object detection model that provide high accuracy with low latency. Secondly, we studied research paper on captioning image taken by blind people, which showed that image taken by blind users require specialized model to provide useful description. The third one, we reviewed the sort and dipsaw tracking method, which help in maintaining object identity across video frames. Our problem statement is clear and focused to develop an Android-based application that assists visually impaired individuals in navigating safely within their environment by integrating YOLO and real-time object detection and OCR technology for detecting and reading text from surrounding.
Objectives. The main objectives of our project is to help visually impaired people move safely and independently in their daily life. Our application is designed as lightweight and affordable mobile solution so that it can be easily used by a large number of users without requiring expensive hardware. The first objective is to design and develop a user-friendly mobile application using React Native. The interface is kept simple and accessible, so blind users can operate it easily through voice support and minimal interaction. The second objective is to integrate real-time object detection using mobile camera. Whenever the camera detects obstacles such as vehicles, people, chairs, or other objects, the system identifies them instantly using YOLO mode. The third objective is to provide voice feedback to the user. Instead of showing only visual output, the application converts detected information into speech using text-to-speech technology. This helps users understand their surroundings and navigate safely. Another important objective is OCR integration. OCR stands for Optical Character Recognition. These features help in detecting and reading text from signboards, documents, and surrounding objects and then converts that text into voice assistance for the user. Now I will explain the system architecture and the workflow of our project. Our system is mainly divided into 3 layers: the user layer, the mobile application layer, and the backend AI engine layer. First, the user interacts with the application using simple touch gesture and voice interaction. Since application is designed for visually impaired user, most operations are controlled using voice feedback and double tap gesture. Inside the mobile application, there are mainly 2 features: Open Vision and Open Reader. Let us first understand the vision module. When the user clicks on the open vision, the mobile camera starts continuously capturing real-time frames from the surrounding. These frames are sent to the backend AI engine. In the backend, the YOLO object detection model processes every frame and detects nearby objects such as people, vehicles, chairs, and other obstacles. Along with the detection, the system also estimates the approximate distance of the object from the user. After processing, the detected information is passed to the controller and then converted into speech using text-to-speech module. The user receives real-time voice guidance such as person ahead 2 meters, chair ahead at 1 meter, fast-moving person. This helps visually impaired users understand nearby obstacles and move safely and independently. Now, apart from the obstacle detection, we also provide scene description functionality. If the user wants detailed understanding of the environment, they simply need to double tap on the screen. The current frame is then sent to the scene description model integrated with Gemini AI. The AI analyzes the entire surroundings and generates a detailed description. For example, it may say, "You are in brightly light computer lab with rows of desks, computer monitors, and blue chairs." This gives user a complete understanding of their surrounding instead of an only obstacle alerts. Now coming to the OCR module, which is Open Reader feature. When the user opens the reader mode, they simply place the camera in front of the book, document, or any text. When user taps on the screen, the image is captured and sent to the OCR engine. The OCR module extracts the text from the image, and then the system converts that text into voice instructions using text to speech. If the text contains if the text content is small, the application reads the entire text directly. But if the content is very large, the Gemini based summarization model generates a short and meaningful summary, which is then spoken to the user. This makes reading faster and easier for visually impaired individuals. So, overall, our architecture combines real-time object detection, scene understanding, OCR, AI summarization, and voice assistance into one intelligent mobile application that improves mobility, safety, and independence for visually impaired users.
Now we will see system modules. This slide explains the main module of our Drishti application. The first module is the user interface module, which provides a simple, accessible interface for visual impaired users with easy navigation and voice interaction support. The second module is the object detection module. This is the core part of the system where mobile camera captures live surroundings and detects nearby objects using AI models like YOLO. The third module is the voice instruction module. After detecting objects, the application converts the information into voice alerts using text to speech technology so the user can understand their surrounding without seeing the screen. The fourth module is the OCR module, which detects and reads the text from signboards, documents, or label and converts into speech from the user. Together, these modules help blind users move safely and independently. The next slide is the technology used. In this project, we use modern mobile and AI technologies to build an efficient assistive application. We use React Native version 0.81 for developing an cross-platform mobile application that can work on both Android and iOS devices. Django 5.2.5 is used as the backend framework to host the object detection model and the manage communication between the mobile app and the server. TensorFlow 2.20 is used to run the AI object detection model as the YOLO V8 for identifying objects in real time. Then REST APIs are used for smooth communication between the front-end application and the back-end server. Then React Native Camera is integrated for capturing real-time images and video frames from the mobile devices. Text-to-speech technology is used to detect object information into voice feedback, helping visually impaired users understand their surrounding effectively. The next slide is requirements. This slide describes the hardware and software requirements needed for our project. For hardware requirements, the application needs an Android device with at least an 8 megapixel camera for accurate object detection. A minimum 3 GB RAM is required, while 4 GB or more is recommended for the smooth performance. The device should have Android version at least 8 or above, along with the internet connectivity and functional audio support like speakers or earphones for voice guidance. For the development purpose, a system with Intel i5 processor or higher, 8 GB RAM and SSD storage is recommended. For software requirements, we use React Native as the development framework and Android Studio with SDK and emulator as the programming environment. VS Code is used for the code editing, and for object detection, we have used TensorFlow Lite and YOLO models are used, while React Native Camera handles the camera integration and React Native TTS provides voice feedback functionally.
Now I will explain the working flow of our project Drishti app. This is the home screen of the application. Here we provide two main modules: Open Vision for real-time environment understanding and object detection, Open Reader for reading printed text aloud using OCR technology. The UI is designed to be simple and accessible for visually impaired users. After clicking on Open Vision, the camera opens and continuously captures live video frame. Using the YOLO AI module, the system detects nearby object in real time. For example, here is the app detected a chair at 2 meter distance and give the voice feedback such as chair detected at 2 meter.
Guardian active. Double tap to describe scene. Chair at 2 meters. Fast chair at 2 meters. Chair at 2 meters.
This helps users avoid obstacles and move safely in their environment. One important feature of our application is double tap gesture. When the user double taps anywhere on the screen, the app captures the current camera frame and sends that frame to Scene Description AI module. The AI then analyzes the complete environment and generates a detailed natural language description.
Analyzing scene. Rows of desks, blue chairs, and computer monitors fill a computer lab.
Now next we will see the Open Reader module. In this module, when we single click on the screen, it captures the video frame and send for analyzing the text and give the summary of the text to the user by voice instructions.
Capturing. Drishti Vision for the Blind is an intelligent, AI-driven mobile application developed using React Native and YOLO-based object detection, providing on-device voice feedback to help visually impaired individuals navigate safely and independently.
Now I will explain the implementation status of our project module. First is a user interface module. It provides a simple and accessible interface with large button and voice command for easy use. This module is successfully implemented. Second is the object detection module. It captures live video from camera and detect object in real time using AI technology. This module is also implemented. Next is a voice instruction module. It converts detected object and scene information into voice guidance to help user during navigation. This module has been implemented successfully. Finally, the OCR module. Read printed or handwritten text from image and convert it into speech for visually impaired user. This module is also fully implemented. So all major module of a district system is successfully completed. To conclude, Drishti is an AI-based assistant system developed for visually impaired individuals. The system uses object detection, voice guidance, and OCR technology to provide a real-time support and improve user safety and independence. Our goal was to create a low-cost, simple, and mobile-friendly solution that can help visually impaired users in their daily life. Overall, Drishti makes technology more accessible and helpful for society. Thank you.